Levy. Those are most of the people know me by those two names. I work in cybersecurity. I work in threat intelligence specifically right now. In the past, I've worked in IR, etc. My background and my specialty is primarily in darknet investigations. I've done talks on the darknet for a variety of podcasts and streams. So lurk somewhere and find me there if anybody's interested. By day, I do a lot of intel, but by night, I do a lot of fun, specifically with programming. I used to stream tutorials on Python 101, which is kind of where this project we're going to go over came from. And I am currently finishing up a master's degree in machine learning and artificial intelligence, where I'm really diving deep into deep learning, pun intended, to do some darknet research, which has been a lot of fun and very interesting. I have a very large dog. Some of you saw her. She will interrupt us. I apologize in advance. She's bigger than I am. She's pulling out every squeaker toy she owns, and I thought they were all dead, but apparently they're not. So I apologize in advance. I also have a very small calico cat. For some reason, my animals, whenever this light is on, realize it's time to be bad and immediately interrupt everything. So just warning everyone in advance. I am also an avid volunteer and ambassador for the Innocent Lives Foundation, and I cannot go through any meeting without telling people that. So if you have not heard of the Innocent Lives Foundation, we're going to fix that right now. The Innocent Lives Foundation is a nonprofit organization that focuses on identifying predators online targeting children and turning them over to law enforcement. So pretty much everything I do online tends to in some way try to lead people to the Innocent Lives Foundation to help support them in their mission. So if anybody has any questions about that, the darknet, or this project we're about to do, every squeaker toy, please just let me know afterwards. Give me 1 second to go steal that toy from my dog.
Thumbs up to the Innocent Lives Foundation. Person who taught me a great deal about coding the dark web was very active in that years ago.
I heard 2 of my favorite words in that, so yay. Well, 3 of them, coding, darknet, and ILF. So I don't know who that person was, but I liked them already. I'm trying to put a screen up on my computer. There you go, so that I'm visible, because I can't see my screen if I turn the light on. So I know I got you the notebooks like hours ago. I don't know if you sent them out to anybody who registered or not. Otherwise, I'll put the link in chat.
I didn't send out, so
that's fine. It's my fault entirely because I'm the worst. So I have anybody who wants to follow along. I actually created 2 Jupyter notebooks and tested them to make sure they work. The type of presenter I am, for anyone who hasn't seen me present before, is very interactive. So please jump in and interact with me. Otherwise, I'll just play the Jeopardy song in the background until someone does. Has anybody used Google Colab or Jupyter Notebooks before? Yeah. Cool. Anybody not use these things? Anybody want a brief introduction to what they are?
Okay. I've used Jupyter, but not Colab, so maybe.
So Google Colab is basically Jupyter Notebooks in an environment that is virtualized and then sent locally to your browser. This way, I set them up so that all of us can open these and interact with them, and we don't have to worry too much about what computer operating system you have or anything like that. This way, we know that everybody is able to run the code the same way, or they should be. I again tested it last night, so it should all work. Because otherwise there can be some discrepancies, as I'm sure most people know, regarding Free squeaker toy. I thought I took that one was dead. Regarding different operating systems and Python, especially because we are going to be using system codes in this program to exit out when there's an error. So in the chat, I posted the link to the GitHub for these two notebooks. You can open both of them if you, I guess I should share my screen. That would be helpful. Hang on. Hang on. Can you guys see my Google? My GitHub, rather. Got to put you guys somewhere on my screen so I can see you. There you go. So I put both of these in here. You should be able to go into either of them. We're going to initially start with the Madlib workshop and just click the open in collab. And it should move you over. We have a little piggy friend for fun. I'm just going to go back so we can stay there. So I know we have about 45 minutes. So instead of going over how to create a spider, which is part of this project, I already wrote it up for you guys. So what my goal in this workshop is to do like a very high level introduction to machine learning and how fun it is and all the fun projects we can do. And for this one, I focused in on doing something that most people I think have at least heard of or done in their childhood, which was fill out Madlibs, even if you did it on a box of cereal at some point in your life, which is when I did it. But I guess they had books out for these at some point. And one day I was sitting around, I was wondering, okay, if we know that people can fill these out, can we get a computer to do it? And what is the most fun way to do that? And we're going to be looking at a library that has a lot of text in it that you can utilize for things like this. But I wanted to see if I also like spiders. If you follow me anywhere, you'll see spiders everywhere. That's kind of my logo and my shtick at this point. So I wanted to see if we could use a spider to go out and scrape text, use machine learning to analyze that text and organize it into the natural parts of the language, in this case, English, but you can do this for other languages, and then fill in a Madlib with whatever text from whatever website. When I first made this, I used the Wikipedia for, what is it, that movie called? The Matrix. And then yesterday when I double checked it, I used Shrek. So it's just very funny things. You can use silly little examples to get fun words to fill in the Madlib. So this is written just as a heads up for everyone. If you want to come back to this, these are going to stay up and published. It's written to be like a manual and to be almost like a class on what are the Jupyter notebooks in Google Colab, and then also machine learning. Quiet doggy. All right, so for those who do know Jupyter notebooks, this will be pretty easy. The first part of this is just an intro to Jupyter notebooks, clicking on links so you can see different things. I put in this distress piggy just to prove that you can put images in these because I use them for notes all the time. And then is everyone who is here today, are you all familiar with the basics of machine learning? No, yes, maybe, kind of. Okay. This section of the notebook is just going over briefly what is machine learning, which is a subset of artificial intelligence in some definitions and part of computer science. It's really focusing on data, especially older data, and utilizing algorithms and methodologies in order to imitate either how a human learns or to achieve a goal and improve accuracy towards that goal over time. Again, we're usually talking about historical data. So today we're going to go out on a website that already exists, grab text that already exists, and then organize it into the basic components of a language that we already know the rules for. And this is kind of, today's project falls under supervised learning. There are multiple different types of machine learning. This is just a few of them. There's supervised, unsupervised, semi-supervised reinforcement learning, which is very cool and very complicated, and really interesting to dig into. So I highly recommend that one. And please, by all means, raise a hand virtually, or if I can see your camera, or jump in with any questions at any point that you guys may have. Because like I said, I like the interaction. Otherwise, I feel like I'm just boring you guys into a nap. And it's a little too early for a nap, a little bit. So today's libraries for this project are gonna be request, SSL, LXML, Beautiful Soup, and the star of the show, which is NLTK. Has anybody here ever used NLTK before? I figured you had. You're nodding to everything I say.
I have not.
I am super interested in what you have to say. I'm just eager to see if you're going to help us build a spider.
Oh, we are about to build the spider. The spider is the first part. So I know we're getting this recorded, so there may be people who are not familiar with Jupyter Notebooks or Google Colab, which I heard that potentially someone who helped make Jupyter Notebooks is going to watch this. I just want to shout out that Jupyter Notebooks is my favorite thing ever. I take all of my notes in this now, and I wish it worked for other languages. So that aside, in order to install any packages that you need, which I don't think we actually need to install any of these, they should already be in here, but just in case, I put in this block to show you how to install them. This is the format that you would use. Now, you'll see that some of them are already satisfied, some of them are getting discarded, it's fine. Moving down slightly, where is it? For the NLTK, it's got some problems with Google Colab. They don't get along as well as Jupyter Notebooks in a virtual environment on your host itself. So I do recommend, and I think I put it somewhere in these notes. Yes. Personally, when I okay. Personally, when I program in Jupyter Notebooks, I do it locally in a virtual environment on my host. And I tend to use something like an Anaconda or PyCharm in order to encapsulate that, though I have just made the virtual environment. There are a few reasons for this. One of them being that NLTK doesn't install everything in Google Colab for some reason, and you can't do any pop-ups. So when we get to the next notebook, which we'll skip to after the spider is created, what you'll see is that there are a few lessons in there that you would have to move into another IDE, like Idle or Spider, shockingly my personal favorite IDE, and in order to get the pop-ups and actually do the chunking. So in order to get all of the different versions of, or the different sub-libraries and modules of NLTK in Google Colab, we have to run this nltk.download. And the syntax is slightly different than you would need in a regular IDE where you could just have the empty brackets. Here you actually have to put all or decide book will also work. There's a few options and they will show up to tell you which ones you can choose. But in this case, we're just going to do all of them. And the reason for that is primarily in order to punct the sentence tokenizer, which we'll talk about in a little bit. So now that we've already got our libraries installed, for those who are not familiar with a Jupyter Notebook, you run each block individually. You do not have to run all of the blocks in order to run the code unless they are dependent on each other. In this case, all but one of them are. But you do have to run the block itself. So if you move items out of order and they're dependent upon that order, you may actually change the outcome of the code. This I've seen primarily when we have Jupyter Notebooks that have to do with data processing, such as if you go to Kaggle, I think it is, and download the Titanic document sheet, which is often seen as an intro machine learning project. If you move where you have your code when you're processing that data, you can actually change either the data, the formatting, etc. Depends on what you're doing. So just keep that in mind, that you want to be very careful with the order of these, and you can change those at any time with these arrows. So we'll run this one just to make sure we have imported all the libraries we need, and you can actually see it sometimes going through each line. They have updated this the GUI here, and you can actually see at the bottom how long it takes to complete, which personally I think is helpful because I made a CAPTCHA breaker at one point, and that could take 5 years to run. So just 5 years. So now I'm just doing the NLTK download. We're not using it yet, but personally, when I design notebooks, I tend to put all of my imports and my libraries together. I have seen people do this per block, and I will show you that in the next notebook. I don't like this because then I feel like I'm gonna re-import things over and over again, and that just seems like a waste of space on the system. So I tend to do it all up the front. Some people like it the other way because otherwise I've been told they can forget what they've already imported or what they plan to use, and I get that. I personally find it just to be a preference. This is going to take a few little bits. There's a lot to download. One thing I do not recommend is doing, forget exactly what the command is, but there's an nltk.download where you can download all of the text that they have. Don't recommend doing that. That's a lot of data. I don't even know if Google Colab has enough disk space allocated unless you have the Pro version. Oops. Oh my gosh. Why do you take so long?
Yeah, it took a few minutes.
Yeah. Last night it was a little bit faster, but I think I did it 7 different times, so it probably was just storing it. So just give this a second. Are there any questions or comments? Am I going too fast, too slow? Explaining things nobody cares about? Let me know.
Well, while that's dying, I have some opinions on this. I think this is done, so let's move on.
Oh no, if you have, go on.
No, just that you built this in Colab, it's fine. And with Jupyter notebooks and everything, but I think, and I have a little bias. I teach another class through This Week in ML. We are almost finishing up the class on data pipelines.
Mm-hmm.
And so we started with Google. And so everything that Google's built up into Vertex,
Mm-hmm.
the pipelines platform, and it incorporates all of this. And then we shifted over to AWS using this book, AWS, Data Science with AWS. It's written by a friend of mine, Christopher Glee at Amazon. So we just went through, basically you could watch Chris and Anta's lesson in about 3 hours on YouTube. They do it every month. You can watch it for free and you can set it up and so on. But you have to be careful because last night I realized I got hit and my co-teacher also got hit with like a $315 charge. So you got to be careful when you work with cloud and code spins off. It's okay. Amazon took care of it. It's supposed to be taken care of in next week. But my point is, we start working with Jupyter notebooks, but in the last 2 years or so, everything's become more of a pipeline. Mm-hmm. And you do everything serverless. You don't really run anything on your own machine anymore. You attach it into the ecosystem, whether you use Google or AWS, where the storage for AWS would be you use S3, mm-hmm. which is fairly cheap, really like cents for massive. And it attaches, and the Jupyter environment that AWS uses, they sort of wrapped around their own product called SageMaker. Mm-hmm. And SageMaker has all of the SageMaker pipelines. So you're still, when you set it up, you go into SageMaker Studio, that's just a Jupyter lab environment. Yeah. And you're using Jupyter notebooks to build out, architect all of the workflows that go into the modern data science, machine learning stack, to a point where because we have AutoML, because we have it's a lot of data engineering, what is traditional IT sort of evolving to managing and supporting that with, you build lots of different models, and you deploy certain models at certain times. Then there's the operational side of it where you track if there's a model data drift and the model accuracy is beginning to change and go below your threshold. Well, then you need to retrain your model and do that. And so all of the workflows is being integrated. And it's effectively how it's now fairly easy, but also kind of hard still, to build and evolve into a company like Uber or Airbnb. So bottom line, short story is, the work of a data scientist or just working through Jupyter Notebooks, that's become smaller, where now the capabilities are, let's turn everyone into a data scientist. In fact, the data scientists really should be the subject matter experts and the subject domain experts, the folks who work in healthcare, the medical side, and so on, who really understand medical data, anything from claims data or radiology images and so on. They're able to use these platforms to build those predictive models. I'll stop there.
No, yeah. I have used SageMaker, and I do use those for other machine learning projects. So I definitely agree with you on that. And I do agree with you on having subject matter experts in the pipeline for those bigger projects, whether they're the data scientists themselves or they are consulting. I have in the past worked in a pharmaceutical and the healthcare industry, and goodness gracious, nobody knows what anybody's saying ever.
Yeah.
I also just read a very interesting book called AI for Lawyers, and they're talking about how they developed all of these natural language processing systems in order to work on the documentation. So I definitely agree with that, and I think it's a great point to bring up.
Yep.
I do think that Google Colab is excellent for people learning machine learning and getting into it, because it does give you that collaborative effort. So that was kind of my goal with using this. Also, I know SageMaker, I haven't looked at the free version in a bit. There was a free version for students, but not necessarily for everyone. I don't know if that's changed.
You can get into SageMaker and still stay free. Just be very careful that when you run it, just like, so we ran on default here in Colab. If you look on the top right of the screen, it says RAM and disk, and there's a little drop down. That's where you can go in and you could actually set it to, I wouldn't do it right now. I think it'll just restart everything, but you can pick a GPU, right? You can pick a GPU or a TPU. In SageMaker, think of it as that choice lets you attach to any kind of AWS machine. The lowest tier, the data science, whatever lowest tier machine would be more or less free. Even if you're charged anything, you'll be charged a few cents.
Yeah,
that's it.
It is extraordinarily cheap now.
It is extraordinarily cheap. And same thing with Google. And our last class that we think we're going to have for this pipelines course will be next week on Wednesday, where we're going to do Google Vertex. We'll try to do everything end to end and go through Google's documentation. So in 2.5 hours, if anyone's interested, we'll cover that whole spectrum of, okay, here's what Google Vertex, how to work with it. Let's set up an environment in Google Vertex. Let's work through Google's pipeline. What's really important there is TensorFlow and TensorFlow Extended, TFX.
Yeah.
TFX is it. And even within SageMaker, what we're doing is you're using TFX built into the pipeline to do just about anything and everything.
Very
cool. Sorry, I didn't mean to slow you down.
It's fine. I already wrote everything, so we're not like, we're not holding up on writing things. Plus, it's interesting. It's fun to talk to. I don't get to hang out with too many people who talk machine learning every day, so I'm down for it. So now we're into the spider. Let's get back on topic. Spiders. So if anyone sees or talks to me about my general spiders, or you see some of the open source spiders I have developed, most of them are ingrained with the Tor network. They're embedded in the Tor network. They work primarily on the Tor nodes. This is not that spider. This is a very basic spider design. I see the disappointment. This one, there's no need to go to Tor. This one is, to be honest with you, I didn't want to know what words we'd pull if we put in a Tor address. So this one is designed just to go to any ClearNet website that you want to give it. Your discretion. Don't share your screen though if it's bad. And get access to all of the text on that screen. So I put in what I am hoping are detailed enough but not overbearing notes, so that if anybody shares this out or comes to this later, goes over this later, that you can see and understand what's going on in each of these blocks. For this first block, we're just trying to set up a connection for the system. We're just trying to access the network. And you will see basically nothing happen every time we hit these blocks until we get to the end. So that's a bit boring, but this is what we get when we do it in notebooks and nothing's happening. The next one is just to ensure that we have a wrapper for the secure sockets. It depends on what you're connecting to, whether or not you even need this. This is basically just setting everything to none and cert free, so it's not trying to authenticate anything. Not necessarily necessary, but I like to use it just to be safe. Now here's the fun part. We've defined a function, and I personally have a lot of fun with try except blocks. I like just shutting things down. I never trust my users. It's part of my darknet history. So instead, I like to give you a fail-safe. So I designed this to allow for 5 broken URLs, basically. If there's no response, or it's a broken website, etc., 404, if we get a response code back that you cannot connect to this website, it is going to be considered a failure. And if it fails 5 times, the program is just going to exit. But if you fail 3 times and then give it a correct URL, it's going to be good to go. It'll just go hunting. Now, 5 is arbitrary. You can put whatever number you wanted. I don't even remember why I picked 5. I just did. So this try block is going to try to connect. If it doesn't connect, it's going to consider this an error. It's going to let the user know that that URL is just not accessible. Communication is key. And then it's going to check the error count. Now, when we get down towards the end of this program, you'll see that when we call this function, we are passing the error count. The error count starts at 0. So we're just incrementing up until we get to 5. At which point it'll say too many attempts. And now is when we have the system exit. So this is why I wanted to do this in something like a Google Colab environment, to make sure that everybody had the same system codes that we could reach out to and call. Otherwise, it's going to call another function that we'll see later, and basically just restart this until we get a URL that works. Now, if the URL works, we bypass the accept and we continue on with the spider. So here we're going to pull all of the HTML from that website that we just, I'm sorry, I skipped a line. We're going to pull all of the data from the website. So it connected to the website, it's successful, we're pulling everything. So if you ever do, let me move you guys because you're at the top of my screen, move you away. So let's go to this. I was trying to figure out how to make deepfakes the other day, because why not? It's fun. And you go to more tools. We go to developer tools. All this stuff, that doc type HTML, all of the elements, all of this information, that is what we're pulling right now. So if we go back in here and I move you all again. So this data response, we're pulling all of that content, everything that you would see if you go into developer tools. And then from that, we just want to clean it up and only get the HTML. Now, I did make a section somewhere. Oh, I put it back in here. It is currently commented out but if you wanted to test this, this would show you what the data looks like before it's cleaned up. It's messy, so I don't recommend it, but if you're curious, I always like to leave those in there. After that, we're going to use eTree to string to pull out only the pretty stuff of the HTML. We want to get rid of all of the code brackets, all of the extra stuff. Get rid of everything that is not necessary so that when we feed it into Beautiful Soup, which we've named BS4 here, because that's the library we're going to use, we can pull out just the text. All we want in the long run is the readable human text, stuff that we can actually start running through our natural language processing portion of this project. So for that scraped text, we're going to clean it up. We're going to create a list of things that are the ends of phrases, sentences, or breaks in the original code, just so that it's a little bit cleaner. And then join that back together so that we have one large corpus of all of the words that we found in that pulled document, pulled website page rather. And then we can pass it on to the next function, which is when we get into the actual machine learning portion of this, which is the natural language processing. I'm gonna hit run on that because I forgot to. So natural language processing allows us to basically break things down into different parts of speech based on whatever language you're working with. For English, we've got too many of them. This is a very short list, but if we pass over to, again, I have to move you guys. If we go over to the other document, the other notebook I created, which again, if you go to that link I put in chat, you'll have access to this one, is the second in this folder. This is just a tutorial on how to do natural language processing with NLTK, which is the natural language processing, or the natural language toolkit rather, library for Python. And this one I'm not downloading all, I'm just downloading the book. It'll still have everything we need, so it should be fine. It also will be a little bit faster. Now, we don't necessarily have to go over this, but what this notebook is focused in on is the different methods of natural language processing utilizing this library. Again, this library has its own collection of texts within it, which we'll see in a little bit. But first, we want to just break down some basics. So for this first block, we're talking about tokenizing. In NLTK, you can tokenize in two methods. You can tokenize by sentence, or you can tokenize by words. And what this means is we're going to break this down into, it's not a list. My brain is blanking for a second, but a collection that's going to separate these items. And one thing to note is that word tokenization will consider a punctuation as a word as a default. So you'll see those separated also in the list. So let's.
It's a dictionary, right?
Dictionary. Thank you. My brain was like, dictionary is the word I wanted. So I created an example text here. Hello, stranger. How are you doing today? The weather is great and Python is awesome. Let's meet later for tea. We can discuss why the sky is a pinkish blue and how that tells us not to eat cardboard. A fun sentence. It has fun words. Don't eat cardboard. So this is tokenizing it out. The first one of these dictionaries is the word. No, I'm sorry. This is the sentence one. So it's breaking up each sentence based on the end of the punctuation. And then we see every single word and punctuation is its own item when we do word tokenization. So I also did I for word tokenization prints so that you can see them all without having to scroll. But that's the same thing as the one above. So does tokenization make sense to everyone? We're breaking up by sentences or breaking up by word and punctuation. I find word tokenization to be a little weird. It's basically, I mean, I guess. And so if everyone's good with that, moving on to the next part, we're looking at, I'm taking so long, oh no. We are looking at how to identify stop words, which I find this one really fun. So I'm just gonna run it to show you so I can explain a little bit better. Basically, we're filtering out all of these words that why does it look like that? Mighten, what was that word? It's taking out all of the stop words everywhere that there's like a pause, and there's look at that, too many words. And then you end up with this filtered sentence based on the way that it's taking out those stop words. So if W for W in words, so each word within that dictionary words, if it is not in the stop words, we're going to create a filtered sentence. So hello, Mr. Stranger. Today, question the weather. Great Python, awesome. Let's meet later, tea. We discuss sky, pinkish blue. Tell us, eat cardboard. So now you're supposed to eat the cardboard. It's changed its mind. I still don't think you should eat cardboard, personally, but you know, this one's fun. I like the stem. So I apologize for anyone who reads this later. I put really bad puns in my notes because these are also my notes when I was learning this whenever ago I learned this one. Because I did not write this for today. These are snippets of code that I had on my computer that I wrote when I was when I was learning this stuff, and then I polished for today. So what a stem is that we're basically getting rid of all the extra fluff at the end of words, so we can identify if we have the same word multiple times. So I don't think I had a great sentence for that, actually. Today, great, awesome, later for tea, discuss what. I didn't really use stems, actually. So that was a bad example. But we're looking for things like ing, ed, etc., things like that. Endings that change the tense or perhaps the meaning of the words a little bit, which can sometimes confuse the system into identifying if you're using the same word over and over again. So if you're trying to see how many times the word meeting is or meet is, you may count meeting and meet as two separate words, but if you remove the stem, you'll see that you're just using the word meet again and again, right? So that's kind of what that is for. I will update that sentence to be better because I just now realized I did not have very many stems in that one, so I apologize. Now's the fun stuff. Now's when we get to download cool things. So like I mentioned earlier, there are two ways mainly I see people who use Jupyter Notebook environments to import from their libraries. In this one, I put it in each code block. In the actual Madlib, you'll see that it's separated. It's all up the front and then all of the code. Here they're together. Each block has its own pulls, unless it was pulled previously. This was just an example to show you the different ways people do it for anyone not familiar. Again, it's your preference. So for this one, we're talking about tagging, and we're actually going to be pulling the text directly from Gutenberg, which highly recommend. Go hang out on that website. Very nice free text to read. And also a few of the State of the Unions. Again, I'm kind of breezing over this because I was timing myself to try to not take up your entire evenings, and I'm realizing that I'm going long. So some of this we're just going to breeze over, but we are getting close to what we need to get back to our spider. So here, what we're going to talk about is, this will make a very fun little table to show you the average word length in everything from the Gutenberg. What is the average word length? What is the average sentence length? The vocab. Sorry, I'm getting a phone call. And the frequency of a vocab word appearing. This is just at a high level on the different documents in Gutenberg to allow you to see what they have, and then you can choose from one of them. And then when we go down a little bit further, this is the table itself. When we go down a little bit further, I've chosen to do my example on the Milton Paradise poem. And so we're going to print the length, how many sentences there are, what is the longest sentence, and then we're going to go and we'll move on after that. But this is just to show you what can this do and how is it processing these texts. And then from there, there's all sorts of fun things you can do, including this tokenizer, which unfortunately, we're not going to get to. This one's a bit of a mess. It's a little bit messy. What this is showing is these are the different grammar groups. And this is what we need for the spider. So here we're showing what part of grammar each of these words that's identifying. And you can see there are some where it splits it at a weird spot. Where do these words go in our grouping for grammar, which we need to fill in the Madlib? Because if you've ever played with a Madlib, you've seen them go, you've seen that a Madlib is like, okay, I need a verb, I need an adverb, etc. So this is what we need. We need to eventually take whatever website we are pulling from, which that website is your choice, and identify what groups all these words need to go in. So we're getting closer to that in this basic tutorial. This is the table. This is the only part of this entire output that looks nice. I would split this up if you want this to be somewhat human readable. The rest of this is when we're getting into the tokenization, or I'm sorry, when we're starting to use the custom tokenizer for the punct sentence in order to try to test this into the parts of speech tags. And then ultimately the tagging, which is for each item in the token. And these are all from State of the Union, which is why it's so long. We are not only using the words to tokenize them to separate by each word, but we're also adding the tag. And these are all of the parts of speech, which in our spider, we will not be utilizing all of them. We're just going to use the basic ones for the Madlib. But I added all of them here so that if you do come back and go through this and you want to use this for something, these are the items that NLTK will actually identify. So you can use these at whichever level you need. And then we go into chunking, and unfortunately, I can't show you that in Google Colab. What it will do is just yell at me because there's no display. So if you want to see how these work, I would just pull this into an IDE, unfortunately, which I do have that version of this code in a repository. So if anybody does want that, just you actually can get it right here. Just let me know. So I'm sorry I blitzed through that. Is there any confusion or questions? Because if there are, it's my fault. So please bring it up. No, yeah, no, maybe. So, good. Okay. So now we're back at the main notebook. So we've gone through the natural language processing. We went through a little mini blitz of a tutorial, which luckily we can all go back to because that will probably be out of our brains very shortly. And we're gonna move on to what parts of speech do we need? Now I chose these parts of speech based on the Madlibs that are later on in this notebook, because these are the parts of speech that we needed. Now in NLTK, you can break down different types of nouns. And that might be important for some project that you're doing. You may need specific proper nouns or that are in plural or singular, for example, or plural or singular nouns or past tense verbs, etc. For our purposes today, we don't need that. So what this function is doing is saying, first off, hey, we've got here. This is our test code line. It's saying, hey, we got your code, we got your URL. It made it through. We have clean text. Let's keep going. So now that we have that text, we are creating these lists where we're pulling in anything that is a noun, anything that is a verb, anything that's an adverb, etc. and an adjective into their own little columns. And we're using another try except bracket to take the corpus, which is the parts of speech we created up here that scrape text, and we're going to tokenize it like we just saw in the other notebook. And then for each tag, we're going to identify if it is a part of the noun list, then it's going to go into the NN, which is our nouns. And so what this is checking is, okay, so if the tag is part of this list or this dictionary, then move that word into our list of nouns. And so we're going to do that for each of these main tags. Everything else, just get rid of it. We don't need that for the Madlibs. Then we have, this will then get passed to another function that we're going to see later on. So we'll run that. So it's good to go. Now we have the word choice. What all this function is doing is randomly selecting what word from that list we're going to use for the Madlib. That's all this is doing. It's just using random to select from whatever list is pushed into the function. And you'll see where we're pushing that in a minute. Now, I did not fill out all of these Madlibs. I did not fully code all of them. I only did, I think, like the first two. I left the other ones for whomever would like to fill out yourselves, to both play with the programming and the formatting of this particular project, but also to better play around with and understand how this works. Everything else, the menus, all of that is pre-programmed, just not all of the Madlibs that are an option here. So those are for fun for you guys to do later if you'd like. And you'll see here, I've listed that every verb that we're going to call is going to be, first, it's going to call the word choice and get you a randomized verb. Same for noun, adjective, adverb. And then here's our little Madlib. And here are where we are filling these in. The next one is about Disney. So I also added some words that had to do with Disney that weren't necessarily going to show up in whatever URL you use. But otherwise, it's pretty much the same. We have our own little kind of word choice here, but then we also have the same idea here where we're doing, okay, we want our friend, we want our vehicle, Disney, adjective, etc. And here you get to name your friend, so that's fun. And then now you can see everyone that has these lines, it's telling you what you need next to it. So if you would like to fill these out later, it's just a guide. You can fill them out however you want, but these are not completed. So I am going to run the code for these two, and we can do either of those. Hey, run. And then we're just going to skip all these because they don't do anything. And then here we are at the Madlib menu, the most important of all of them, because otherwise we can do nothing. Once we get to the menu, after we have supplied our URL, we can choose which of the Madlibs we want to do. In this case, we only have these two pre-programmed, so we can't do anything else until we get those done. Otherwise, whenever you guys, if you want to go in and program these, you can do that at your leisure, and then you can fill in any of them. If something is invalid, it will just send you back to the beginning of the menu. An infinite loop of sorts. Finally, with the last two blocks, we almost can do it. We're almost there. For the user input, we're just letting you put in the URL, very simple. And then you're going to go to that first function that we made up at the front and pass on the error count. Now, finally, this is the beginning of our lovely spider to go out and fill in our Madlibs. And all this is doing is telling you, is just starting this up. You get an error count of 0, and you will continue here until we are done. And then when this is completed and it ends, if it has completed all the way through, it will come back to this moment and tell you that it's time for your spider to take a nap before it closes out the program. Otherwise, you'll get a different error message. So somebody give me a fun idea to look up something to be our URL.
Madlib Wikipedia page. I didn't know what Madlibs were.
That's fine. That's fair. I can spell. That's not true at all. I can't spell. It saved my life. Fine.
And I can verify, back in my day, they did come in books.
They did. I
Mhm.
see. I've seen books, but I've never actually had a Madlib book. I just did them on the back of cereal boxes.
They're for road trips.
That's fair. That's
It
true.
Yes.
Okay,
Yes.
that's fair. So I ran this one. We've run everything at this point. So we have, what is your URL? And I always forget that you actually have to use your keyboard.
Control V.
Yeah. My keyboard was hiding under my DS. All right, it got it. So let's do, again, under my desk. Uh-oh, what happened? Nothing, it actually
Yeah.
worked. I don't know. Oh, so when you run this on your system, it will not say there's a system error. When you run it in Google Colab, it will get upset and tell you that there was a system error because you're using the system codes to close it out. Technically, I guess you don't have to do that, but it's a safety thing. I work in security, okay? This is what we do. Here's my minutes. So this did fill it out. The day I saw the Monkey King with MF was the most interesting day in years. After he did that, the king played chess on his brother's mixtape, that then combed his as the hair with the comb, the fish bones. Later that day, I saw the Monkey King dance reportedly in front of an audience of kangaroos and wombats. Sometimes it'll make sense, sometimes it won't. I think that's the nature of Madlibs, honestly. I'm gonna do it one more time just to show that it is fun, and I'm gonna use the same URL. So we're gonna play it again. I always forget. Keyboard, why are you doing this to me? All right, so what do we get this time? The day I saw the Monkey King working was one of the most interesting days of the year. After he did that, the king played chess on his brother's job and then combed his retrieved January hair with a comb made out of old fish bones. Later that same day, I saw the Monkey King dance, first in front of an audience of kangaroos and wombats. That one actually somewhat makes more sense. It's kind of funny. It's not as silly. So this is just, it's a very simple little fun game. It's just, if you're on a road trip and you have this on a local environment, I guess you could play it. But generally speaking, it's just supposed to be a little fun project to get to know natural language processing, the different parts of speech. Personally, I think this would be a fun way if you were teaching kids machine learning to teach them the parts of speech and at the same time machine learning. And I designed this to be an intro to machine learning to get people interested. So hopefully it works. But hope you enjoyed my little spiel. And I hope these notebooks would be useful.